Okay, physicists, in this video we are going to use a spring scale to measure the force acting on something. In particular, we are going to hang an object off of the spring scale and make sure that that object is at rest. So here is an example of a spring scale. You can see that there is a hook, and if I pull down the hook, there's a little device that goes down as I pull harder, because on the inside there is a spring that stretches as I pull down. Another version of a spring scale, you might see spring scales that look like this. Same idea, there's a hook, you pull it down, the spring extends. This one is obviously not as heavy duty as the other one. You might even see a spring scale, if you're really retro, look like this, which you can't see the spring in this one, but it's the same idea. I pull down and there's a spring that the more it stretches, the more the indicator moves around. So if I were to hang an object, maybe I'm hanging this hot glue gun off of a spring scale. And if I let this object come to rest hanging off of the spring scale, I know that if something is at rest, not moving up or down or side to side, that means it is in equilibrium and all the forces acting on it are going to be balanced. So there are two forces acting on this object right now. You have the force from Earth's gravitational field, in other words, the force of gravity or the weight pulling down on the object. And you have the force from the spring pulling up on the object. And our spring scale actually measures the tension in the spring. If I was to bring up a close shot of this spring scale, you can see that there's a little plunger here. It's an indicator in newtons, and as I put more force on the spring, this indicator moves up and down so I can read how many newtons it is. So for example, if I was to put it right here, the top of that little plunger lines up with 3, so that's 3 newtons. And just like a ruler, there are increments in between each number, and there are actually 10 increments. So each of those little hash marks is 1/10 of a newton. So right here would be like 3.1, and then that would be 3.2, going on to our next guy. We're looking at the very top of the flat part of this little plunger here, at least on this spring scale. On other styles of spring scales, for example, I have this one. It's a much lighter duty spring scale. You can see that it maxes out at 2.5 newtons, whereas this green one maxed out at 5. You can see that again, each little hash mark indicates 1/10 of a newton between 0 and 1. And I just have to look for where this little stopper goes. So I'm going to put a little force on this spring and I'll stop it, let's say right here. That would be 0.8. Okay. The other spring scale, one of the circular kind, the newtons go around 1, 2, 3, and just like before, there's 10 little lines, so each hash mark indicates 0.1 of a newtons. And so if I was to pull, let's say this much, that would be 3.3. Okay. So when you measure with a spring scale, you first have to pick the right spring scale for the job. So if I wanted to measure this hot glue gun and I picked this spring scale, notice that this spring scale, newtons is on the right side for this guy, this spring scale maxes out at 50 newtons. Now 1 newton is about 1/4 of a pound, so 40 newtons would be 10 pounds. And I would be impressed if this hot glue gun weighed 10 pounds. So let's see what happens when I put this glue gun on the spring scale. But wait, first, I have no weight on this spring scale. There is something wrong with this picture. Before we measure with our spring scales, we have to zero them. In other words, this little, I'm gonna call it a nub. If I have 0 newtons pulling down on the spring, that little indicator, more professional than nub, should be at 0. When you have a metal spring scale like this, and it has a little tab, now this one actually is nice, it tells me to adjust 0 setting. It has little arrows. I need to pull up on that tab, and I can slide the scale. So I can slide it till when it's, not having any weight on it, it is truly at 0. So let's put this hot glue gun on this spring scale, and let's see what the weight is, how much tension is put into the spring to balance out that force of gravity. Off camera struggling. Okay, it is now hanging on the spring scale, and you can see that the phone is not tilted. There we are. Here we go. It barely moved the indicator. So this is way too heavy duty of a spring scale for this job. So let's try the light duty spring scale. Let's try this one. This spring scale goes up to 2.5 newtons. And if I hold it straight up and down, no weight is on it, I can see that the top of this plunger, the flat part, is roughly at 0. But if I wanted to adjust it, there is a white screw at the top here. And when I, go one way, the plunger goes down. And when I go the other way, the plunger goes up. So I'm gonna adjust this little screw while holding nothing on the spring scale until this little top of this plunger here is at 0. And then I'm going to hang this hot glue gun off of the spring scale. And off camera, we can see that it maxed out my spring scale. I need to pick a different one. It's like Goldilocks. This spring scale's too weak. We need something that's hefty, not wimpy. So let's pick the green spring scale. Colors will vary based on what you have available to you. Now this green spring scale looks a lot like the one before, so we're gonna zero it in a very similar manner. However, notice that the plunger is kind of like upside down, whereas this guy had the spring above it and the flat part of the plunger was on top. This guy, the plunger is on top of the spring, and the flat part of the plunger is on the bottom. So we actually have the zero screw on the bottom here, and if I twist it one way, we can see the plunger went up a little bit, and if I twisted it the other way, we can see that it starts the plunger down. So I'm going to go ahead and adjust this until the flat part of the plunger is at 0. Close enough. And then I'm gonna hang this hot glue gun off of this spring scale. And when it's hanging here, I can see that I finally found a spring scale that is just right, because it's not maxing out the spring scale, and I can see pretty clearly that we're right at 3. Of course, my hands are shaking a little bit, sorry about that. But the plunger was basically right at 3 newtons. So that tells me that the tension force in the spring scale was about 3 newtons. I don't like this marker. Which means that my force of gravity, since it was roughly at rest, must also be 3 newtons. And that is, of course, the force of gravity, which is the same thing as the weight. So there you have it. That's how you use a spring scale. Hope that helped.